Welcome to ClickMyProject.com. Now we are going to discuss about the project, a novel chaotic permutation substitution image encryption scheme based on logistic map and random substitution. Now we are going to discuss about the abstract of the process. Digital image processing is the process of image in order to improve its the clarity and quality of the image, as well as due to the need of the security while sending the image and to the receiving the images. In present days, many of the approaches focus largely on the reversible data adding in encrypt and decrypt the images so it can be maintain the first rate quality of the original images can be easily improved without any loss of the pixel after embedding the data, or else the after embedding the image into one image, or else after embedding the text into one image. So in every previous techniques, embedding the data by reversibly vacations rooms from the encrypted images, which may be causes of some flaws on the data extractions and image restorations. Hence, in this process is applied to improve the quality of the pixel as well as to minimize the loss of the pixels by improving the encryption scheme also. Hence, this method improve the security of the image and to improve the quality due to the receiver side by minimizing the loss of the data. The loss of the data will be evaluated by means of the mean square error, and then the quality of the pixels will be evaluated by using the peak signal to noise ratio, that is the PSNR. Now we are going to discuss about the flow diagram of the process. This overall flow diagram is separated into two things. One is the sender side and then the another one is the receiver side. At first, the input image is taken from the dataset. Dataset consists of the some images. After selecting any one image from the dataset, the pre-processing will be carried out. In this project, only the resource is applied for the pre-processing. After doing the pre-processing, room reservation is carried out to separate the image into four blocks. First of all, the first block is the first room, then the second block is the second room, then the third block is the third room, then the fourth block is the fourth room. Likewise, it will segregate the image into four patches. Those room will be created automatically. After doing the room reservation, the data embedding is carried out to embed the corresponding text data into one image. After embedding the data into one image, the encryption is carried out to encrypt the image as well as the data. After doing the encryption, during the encryption itself we have to give the appropriate key, so based on that key only it will be encrypted. So after doing the encryption everything, we just move to the receiver side. In this receiver side, the encryption process is reversed by means of the decryption process. So decryption is carried out to extract the data. First of all, the data will be extracted, then the image will be reconstructed, then afterwards the performance will be evaluated. So in this data extractions, in case if there is any embedded data is there in the sense, it will be extracted separately and then decoded separately. After that, the image will be reconstructed to get the original quality of the image. Then finally, performance is evaluated by means of the PSNR, MSC, SSIM and time. Now we are going to discuss about the running procedure of the process. At first, open the Matlab 2019B and then change the current directory as it is in the main file folder. After that, if you want to execute the file, we have to right click in the main file.em and select the option run. After doing the selection of option run, the dataset will be open. In that dataset, you can select any one image from the dataset. After the selection of the image from the dataset, the corresponding image will be processed one by one, both for the encryption as well as the decryption. So in between, we have to give one thing as an input. Here we have a 4-patch segmentation. Here I am entered the patch number 1, in the sense the room will be reserved as an 1. So and then we have to enter the key. am saved in the name of new. So once again we have to import the new image, then we have to import the decryption key also. Now the process was done completely. I will explain the results one by one. First of all, the input image is taken from the dataset. Those images shown in the figure 1 with the title of input image. After getting the input image from the dataset, the pre-processing is carried out by means of the image resize. The image will be resized in the size of 256x256. You can see the difference between the size of the input image and then the size of the resized image. After doing this one, the filtering is carried out. In case of any noises is present in the image, those filtering is applied to remove the noisy pixels from the image. After that, the patch segmentation is carried out. In this 4 patch and 16 patch segmentation will be there. Mostly we concentrate on the 4 patch segmentation. First of all, we have to enter the 4 patches number. So in case I am entered the number 1 as an patch in the sense, so those particular patch will be encrypted and then the final encrypted will be shown like this. This is the image of the decrypted image. Then the performance like PSNR, MSC, execution time, encryption time, decryption time and correlations will be evaluated, everything. So finally the PSNR and MSC values are plotted as in graph format. Thanks for watching this video.